Hello students, welcome to Marine Engineering Tutorials. I am Atul Kumar Gupta and I am back with a new tutorial. Presently we are studying marine boilers. In this lecture we will first learn about the construction of boiler shell. Next we will study about various destructive and non-destructive tests carried out to assess the properties of boiler shell material. Then we will study the procedure for tensile testing to determine the strength and ductility of material. Next we will learn about the impact test procedure to measure the toughness of material. Then we will study about the bend test procedure to determine ductility and crack resistance of material. Next, we will explore the procedure of non-destructive testing to examine the crystal structure of metal to check welding and heat treatment defects. Finally, we will study the hydrostatic testing procedure to confirm that the boiler can withstand the design pressure. Let us now go through each of these topics one by one in the following slides. Construction of boiler shell. Before a boiler can be put into service, certain destructive and non-destructive tests are conducted to assess its strength. For this purpose, a test plate representing the true properties of the boiler shell material is attached to the boiler shell during its fabrication. This sketch illustrates the construction stage of large water-tube boiler shell, which consists of two plates, a wrapper plate and a tube plate, joined by double butt welding. The boiler shell is formed by welding the rolled sheets, preferably using specialized techniques such as electroslag welding. The longitudinal seam of the boiler shell are radiographed to detect any defects such as porosity, slag inclusion or cracks, etc. Any defect identified is rectified by grinding and rewelding. The test plate is detached and the disc ends are then welded, following the same procedure. Opening for the manhole and mountings are made and stub pieces are attached to the boiler. The boiler shell and test plate undergo heat treatment through the annealing process. This process removes internal stresses caused by rolling and welding, improves ductility and refines the grain structure. Annealing involves heating the material slowly in a furnace to approximately 600 to 650 degrees Celsius below the critical temperature of 723 degrees Celsius, above which phase transformation occurs. The material is held at this temperature for 1 to 2 hours and then allowed to cool down slowly. The cooling rate is determined by the desired material properties. Tests conducted on the test plate. This test shows two test plates joined by a welding seam. After the heat treatment, various test specimens are prepared from the test plate to carry out following tests. Tensile test of all weld metal is conducted to assess the strength and ductility of the welded seam and on the joint to evaluate the strength and ductility of the boiler shell. Tensile test of the joint is conducted to assess the strength and ductility of boiler shell. Impact test of inner and outer surface is performed to determine the notch brittleness of the material and its ability to withstand impact. Bend test of inner and outer surface is carried out to check the ductility and crack resistance of the material. Micro and macrographic examination is carried out to see the crystal structure of metal. Part of the test plate is retained for retests if required later. Procedure for these tests are described in the following slides. Tensile test procedure. This test shows a tensile testing machine used to find the strength of metal. A specimen of required dimension is prepared and 2 marks are punched specifying the gauge length. The specimen is held by holding grips. Tensile load is gradually increased and the elongation of the material is measured by extensometer until material fractures. A built-in arrangement plots the stress strain curve until the specimen breaks. When the specimen breaks, increase in length and reduction in diameter is measured to find the ductility of material. Stress strain curve for steels. This diagram illustrates the stress strain curve generated by tensile testing machines built-in arrangement. In the elastic region, stress strain curve has a straight line relationship where the material regains its original shape after the removal of load. Strength at yield point is known as yield strength, which should never be exceeded when the component is under load. Otherwise, it may fail. While designing a component, a factor of safety is considered to keep the stress within elastic limit. When the load is applied beyond the yield point, material undergoes a plastic deformation. Highest point on the curve provides the ultimate tensile strength. Beyond this point, material starts to flow, causing a reduction in diameter, and ultimately the specimen breaks. Yield strength and ultimate tensile strength are obtained by using the formula. Yield strength is equal to yield load divided by original area, and ultimate tensile strength is the maximum load divided by original area. Broken specimen is joined to obtain the minimum diameter and distance is measured between reference points to know the elongation. Percentage elongation and percentage reduction in area are measures of ductility of the material which can be calculated by the formula. Percentage elongation is equal to final length minus original length divided by original length into 100. Similarly, percentage reduction in area is equal to original area minus fracture area divided by original area into 100. Impact test procedure. This test shows impact testing machine which is used to measure impact resistance or toughness of the material. A notched test specimen is securely clamped in a vise and fractured using a swinging hammer. The hammer is initially held at a specific height, giving it a defined initial energy. Initial energy is shown on the energy indicator. When the arm is released, it strikes the specimen which may fracture it. After the impact, the hammer arm engages a pointer which is carried along for the remainder of the swing and indicates the remaining energy. The difference between the initial and remaining energy represents the energy absorbed in fracturing the specimen. This measurement provides an assessment of the material's notch brittleness and its ability to resist crack propagation. Bend test procedure. The sketch shows a bend test machine used to check the ductility and crack resistance of the material. The machine consists of a die and plunger with dimensions specific to the size of the specimen. The die is equipped with two retainers to hold the specimen in the correct position. Two rounded shoulders are provided on the die to guide the specimen when load is applied on plunger. After the bend test is completed, the specimen is checked for any cracks which should not appear if the material has undergone proper heat treatment. Typically, 3 tests are performed and the results are averaged. This test is particularly useful for detecting changes in the material caused by heat treatment, hot or cold working and casting, which cannot be identified by other testing methods. Non-destructive tests on boiler. Non-destructive tests are carried out to see the welding defects and to study the crystal structure of the metal. Preparation of the test piece. Test piece is prepared by grinding and polishing until scratch-proof surface is viewed with naked eye. It is then washed with alcohol and water to remove grit and grease. The test piece is then etched with acid solution consisting of 2% nitric acid and 98% methylated spirit to remove thin layer of amorphous metal. Macro examination. The specimen is examined for cracks, porosity, weld structure and heating effects under a magnifying glass of power 10 times magnification. Micro examination. The specimen used for macro examination is then used for microscopic examination. This test is conducted to observe the metal structure, which should be pearlite. The presence of martensite indicates that the metal has undergone hardening. Microstructure of test piece. Microstructure of the test piece indicates about the quality of heat treatment. These pictures show microstructure of perlite and martensite. Perlite is desirable microstructure, whereas martensite is undesirable due to poor heat treatment. Perlite is a two-phased plate-like structure composed of alternating layers of ferrite and cementite, which occurs in some steels. Perlite forms under specialized condition of slow cooling. Clear visibility of this structure requires 3000 times magnification. When the cooling rate is faster, martensite is formed, which is very hard and has needle-like structure. This structure is easily visible with 100 times magnification. When martensite is observed, material is heat treated again to get the desirable perlite microstructure. Hydrostatic testing of boiler. After the erection of a new boiler or after carrying out extensive repair, boiler is subjected to hydrostatic testing with the following procedure. Isolating the boiler. All the mountings are removed and stub pieces blanked off except for air vent. Filling water in the boiler. The boiler is completely filled with water from the air vent to remove any trapped air. Connecting a test pump. A test pump is connected to the air vent. Pressurizing with the test pump. The test pump may be hand operated as shown for testing small units or may be power operated for large units. Checking for external leakages. The pressure parts of the boiler are subjected to 1.5 times their design pressure. Pressure is measured by a calibrated pressure gauge. Releasing pressure and draining water. The pressure is maintained for a period of 30 minutes, during which no pressure drop or external leakage should be visible. Commissioning of boiler. Upon satisfactory completion of the hydrostatic test, the boiler is relieved of the pressure and water is drained. All mountings are connected and boiler is commissioned after floating the safety valve. This completes the study of destructive and non-destructive testing conducted on boilers' pressure parts. This book has been written by me and covers all the topics as per Indian Maritime University syllabus. It explains key concepts using simple illustrations. The book also includes answers to all questions that have appeared in examination conducted by Indian Maritime University. It will help students prepare effectively for the exams and also support them in working safely with ships' boilers. I hope you enjoyed the lecture. Feel free to share your feedback in the comment section. If you found the tutorial helpful, consider sharing it with your friends. Subscribe to the channel to stay updated with the upcoming tutorials. I'll be back soon with a new lecture. Thank you for watching till the end.